Okay, so we're going to start down here. Well, first thing we're going to do in curve sketching is find the critical points. So we set the derivative, which is what we're given. We're not given the function. We're not given f of x, but we're given f prime of x. So we set that equal to 0. We factor on x squared, get x minus 3 equals 0. And we split it, so we get 4x squared equals 0. And x minus 3 is equal to 0. So we know that the critical points occur at x equals 0 and x equals 3. We'd also like to know what the signs are in between. So we look at, okay, if this is 0 and this is 3, what's happening to f prime in each region? We can test a point like -1, and we're just looking at the sign. When we plug in -1 into f prime, we get positive number times a negative number, so we get negative values on this region. If we plug in x equals 1, right, we get a positive number times a negative number, so it's still negative in this region. And then when we plug in something like x equals 10, right, we get a positive number times a positive number, so it's positive in this region. We also need to know what happens to f double prime, so we take the derivative of f prime. We get 12x squared minus 24x, right? And we set that equal to 0 and solve because, again, we want to know what's happening to the signs here. We factor out 12x, x minus 2 equals 0, right? And that's x equals 0 and x equals 2, right? And those are the places where f double prime is 0, so we want to check what the signs are in those regions. So if we look at x equals 0 and x equals 2 and plug in points into the second derivative, like -1 again, right? We get a positive number times a negative number, so it's, negative number times a negative number is positive in this region. In between 0 and 2, we would plug in 1, and we get a positive number times a negative number, so the concavity is now concave down in between 0 and 2, and then positive in the region to the right of 2. So we get the graph that we're going to get is going to look like this, right? And we want to know what f prime looks like in these regions. We know that x equals 2 is an important point for f double prime. X equals 3 is an important point for the first derivative. And if we look at this, we have negative values of f prime all the way until this point, and then it changes to positive. And f double prime right, has positive values until you reach 0, and then it changes to negative in between 0 and 2, and then it goes positive for the rest of the time. Now, so now that we know the combination of f prime and f double prime in each region, we can look at each of these 4 rules, 1, 2, 3, and 4. And it's essentially like we're going to copy and paste each of these arcs into the different regions that they correspond to. So for the first region, to the left of x equals 0, we have f prime is negative and f double prime is positive, so we're going to get this graph, right? So if we put that graph in here, right, we get something that looks like that, and it goes all the way until x equals 0. Now it switches to f prime is negative and f double prime is negative, so we have this one now, so it's going to look something like this. And then we switch back to the first one, so it's going to look like this again, right? And then now in the last region, we have f prime and f double prime both positive, so now the graph is going to look something like this. And we end up finishing the graph with a smile. So that's the curve sketch. It's important to understand both the combination of the sign of f prime and the sign of f double prime, and how in each region you can put one of these 4 arc pieces together, and when you string them all together, that's what you get for your possible sketches.